This morning, April 19, 2026, Blue Origin launched New Glen, the first stage booster, flying on previously used hardware for the first time in the rocket's history, separated 3.5 minutes after liftoff and landed on the drone ship Jacklyn in the Atlantic Ocean 6 minutes later. New Glen stands 98 meters tall, carries 45 metric tons to low Earth orbit, and delivers over 20 metric tons on a trans-lunar injection trajectory, the path toward the Moon. It is not just a commercial launch vehicle. It is the rocket Blue Origin is building its entire lunar architecture around.
GCOSM before and post liftoff. Fire inspection suite using LC-36 command cameras.
Great shot looking back from New Glen as it soars to the sky. We're about a minute.
New Glen's first stage is powered by 7 BE-4 engines burning liquid oxygen and liquid methane, a cleaner propellant combination than the kerosene-based fuels used in older rocket generations. But what you are seeing at the base of the rocket during liftoff, that distinctive bell-shaped exhaust plume that spreads wide and then narrows into a bright structured core, is a direct consequence of the ambient pressure at sea level interacting with the engine nozzles. At sea level, the surrounding atmospheric pressure is relatively high, and the exhaust exits the nozzle slightly overexpanded, meaning the atmospheric pressure is actually compressing the plume inward after it leaves the nozzle, creating that characteristic narrowing and the visible shock diamonds, the repeating bright patterns inside the exhaust column. As the rocket climbs and the atmospheric pressure drops, the plume expands outward and the shock structures disappear. The shape you are watching change in real time is the engine responding to a continuously thinning atmosphere, the exhaust finding its equilibrium against less and less resistance with every meter of altitude gained.
Less than 1 minute to MECO, which is main engine cutoff.
The fairing sitting on top is 7 meters in diameter, twice the internal volume of a standard 5-meter fairing, which is what allows it to carry physically large payloads like the Blue Moon lander in a single piece, without folding or compressing the hardware. This mission carries a single satellite, BlueBird 7, built by the American company AST Space Mobile. The purpose of that satellite is straightforward. It is part of a growing constellation designed to connect ordinary smartphones directly to space, without any special equipment, without a ground tower anywhere nearby. And now, the booster separates. You can see the clean break between the two stages, the first stage falling back toward the ocean, while the upper stage and its payload continue upward on the 2 BE-3U engines that take over from this point. The second stage is optimized for vacuum. Its nozzles are significantly larger than the first stage engines because in the absence of atmospheric pressure, there is nothing to constrain the exhaust expansion, and a wider nozzle extracts more thrust from the same amount of propellant.
Everything's looking nominal, GS2 ignition in full thrust. We have payload fairing separation.
As the booster descends back through the atmosphere, it is solving a continuous navigation problem in real time. The onboard flight computer is processing data from inertial sensors, GPS receivers, and radar altimeters simultaneously, comparing the rocket's actual position and velocity at every fraction of a second against the pre-calculated trajectory it needs to follow to reach the drone ship.
We've got our long-range cameras out on the booster. Yeah, we're hyped too. Well, it isn't.
Any deviation, A gust of wind, a slightly off nominal burn duration, a fraction of a degree of attitude error gets corrected immediately through two systems working in parallel. Lower in the atmosphere, as aerodynamic control becomes less effective and the terminal burn approaches, the engines themselves vector their thrust. The nozzles physically tilt to redirect the exhaust and push the booster onto the correct line. The landing burn ignites at an altitude calculated to bring velocity to near zero at the exact moment the legs touch the deck, a timing problem that involves knowing the booster's mass as propellant depletes, the local air density, the motion of the drone ship on the ocean surface, and the residual horizontal drift simultaneously. The drone ship itself has azimuth thrusters that holds its position within a few meters regardless of sea state. The total horizontal accuracy at touchdown is typically within a meter or two of the center of the landing pad. That precision is not mechanical luck. It is the output of a control system running faster than any human reflex on a vehicle that has been falling from space for several minutes and has exactly one attempt to get it right. As it re-enters the upper atmosphere, it deploys grid fins, 4 aerodynamic control surfaces that extend outward from the body of the booster and steer it through the thickening air. The final landing burn ignites close to the surface, slowing the booster from hundreds of kilometers per hour to nearly zero in a matter of seconds, and it touches down on the drone ship Jacklyn on 4 deployable legs. The visual is nearly identical to a SpaceX Falcon 9 landing, and that is not a coincidence. The fundamental engineering logic is the same, a propulsive vertical landing using the same engines that launched the vehicle. The meaningful differences are in the scale and the propellant. New Glen's booster is significantly larger than Falcon 9's, and it burns liquid methane rather than kerosene. Methane leaves far less residue inside the engine than kerosene, which means the refurbishment work between flights is substantially less intensive. Less carbon buildup to clean, less degradation per cycle. Blue Origin designed New Glen's first stage for a minimum of 25 flights from the beginning. SpaceX arrived at high reuse rates through iteration over many flights. New Glen is attempting to build that durability in from the start.
welcome back once again. Never tell me the odds. It's good to say that twice, Alice.
Oh my gosh, it sure is. Look at that shot of GS1 on the landing pad.
What you are seeing in the exhaust plume at this moment is the shock diamond pattern again, but now in reverse context. The engines are fighting gravity rather than escaping it, and the plume is interacting with the drone ship deck itself. The exhaust gases reflecting back upward around the descending vehicle in a visible pressure wave. The 4 landing legs deploy a few seconds before contact, locking into position and spreading the landing load across the widest possible base to prevent tipping. Then, contact. The engines cut. The booster stands still on the deck of a ship that is moving on ocean swells, held in place by gravity and the geometry of those 4 legs. 45 metric tons of reusable hardware that launched a satellite into orbit 20 minutes ago and is now ready, in principle, to do it again.
Minutes into flight, because of course the show isn't over. The booster is back, but GS2 is going to be delivering our payload for AST.
Yeah, the next milestone coming up for GS2 is going to be SECO-1. We should see that here shortly. We'll watch along again on the timeline.
On the bottom of your screen. Yeah, that's coming up at about the 13-minute mark. Now, SECO-1 stands for Second Stage Engine Cutoff Number 1. The upper stage finishes its first burn and starts coasting.
And then about an hour and 10 minutes after flight, after liftoff, SECO-1, which is the second engine cutoff, again, for the second time, but a shorter burn. That burn fine-tunes the orbit.
That is for our AST customer, the BlueBird 7 satellite. Big shout out to our friends at AST who are tuning in today. Never tell me the odds. A perfect name if you ask me, Alice. Hey, Team Blue, we hear you. The best part of being here, Alice. Team Blue shows up time and time again.
What you are looking at in this footage is Endurance, Blue Origin's Blue Moon Mark I lunar lander, named after Ernest Shackleton's legendary ship that reached Earth's South Pole, because Endurance is heading to the Moon's South Pole. This specific test is a thermal vacuum chamber test, or TVAC, a ground facility that replicates the conditions of space. Hard vacuum, extreme temperature swings between direct sunlight and shadow, the same environment the spacecraft will face during its actual mission. The high-gain antenna being deployed here is the system that will maintain continuous high-bandwidth communication with Earth during the flight and after landing near Shackleton crater, transmitting telemetry data, engineering readings, and video from a location on the lunar surface that has never been visited. The antenna has to fold compactly enough to fit inside New Glen's 7-meter fairing during launch, then deploy reliably in vacuum and temperature conditions that would cause standard mechanical components to bind, warp, or fail entirely, which is exactly why you test it in a chamber that recreates those conditions on the ground before you trust it 384,000 kilometers away where no one can fix it. Endurance has now completed that testing and is arriving at the Space Coast for final integration with New Glen ahead of its Pathfinder mission to the lunar surface. The rocket that just landed on the drone ship this morning is the same rocket that will carry it there. NG-3 is complete. The booster is on the drone ship. The satellite is in orbit. And Blue Origin has now demonstrated for the first time that a previously flown New Glen first stage can be refurbished and reflown without performance loss. That is not a minor footnote. It is the entire economic foundation on which the next phase of the program rests. Endurance is on the Space Coast. The BE-7 engine that will lower it onto the lunar surface near Shackleton crater has completed its hot fire tests. New Glen has now proven twice that it can reach orbit and recover its booster. The pieces are in place. The Blue Moon Mark 1 Pathfinder mission to the lunar South Pole is the next major event in this sequence, an uncrewed landing demonstration that will validate the propulsion, avionics, and cryogenic systems that the crewed Mark 2 lander will inherit for Artemis 5, currently scheduled for 2030, when Blue Origin's crewed Blue Moon Mark 2 lander is contracted to carry astronauts to the lunar surface for up to 30 days. 13 days ago, 4 humans flew farther from Earth than anyone in history and came home safely. This morning, the rocket that will carry humanity's next lander to the moon proved it can be reused. The pace is not slowing down. The moon is not a destination anymore. It is becoming infrastructure.